In this demo, I'll be showing you how to create and utilize lifetimes. I have a small program here containing ID cards, and the ID cards have name, age, and the city of residence. What I want to do is borrow from the vector of complete ID cards and make a filtered ID card list, say based on age or location. I don't want the ID cards to be duplicated, I just want to borrow them because we don't need to change the cards and we don't want to have duplicated data lying around. We have a cards structure here, and that just contains a vector with all the ID cards we'll be working with. We have a city enumeration, which has the locations where people can live. We also have an ID card structure, which has the name, age, and city of the person who holds the ID card. We have an implementation on the ID card, which just creates a new one. And we have a function that returns a listing of cards in our card structure and just creates multiple cards. So what I want to do is create a structure that borrows the existing ID cards. So we're going to be borrowing these cards here, but we're going to filter based on the age of the person holding the ID card. To do this, I'm going to create a new structure. I'm going to call it young people. And for the young people structure, we're going to derive debug. That way we can print it out later. And we're going to have an inner vector, and we're going to borrow existing ID cards. Now, since we're borrowing here, if we try to compile it, we're going to get an error indicating to us that we need lifetime annotations because we have to tell the compiler that these ID cards exist somewhere else in the program. So I'll add lifetime annotations. I'll just use tick A, and we add the tick A right here after the ampersand. Now that we've added these lifetime annotations, Rust knows that these ID cards will exist outside of this young people structure. The next thing we need to do is create our young people structure. So we'll just call it young. We'll create a new young people. And we'll set the inner vector. So we'll get the existing IDs. We'll iterate over them. Then apply a filter. And we'll check to see if the age of the ID is less than or equal to 20. And then we'll just collect it into a new vector. That way we can use it for our young people structure. The next thing we're going to do is print out the IDs and the young people IDs to ensure that we've done this correctly. So I'll use a for loop. And then we'll print out the young people as well. Okay, so we'll print out all the IDs first, followed by the young people IDs. Let's hop on over to the terminal. And it looks like I forgot to call the iter function. We'll use the inner value. All right, let's try that again. So here we have all of our IDs. So we have 5 total, and they're just different ages. And now we have the young IDs only. So we have age 1, 10, and 20. Our age 30 and 40 people are no longer included within this printout down here. Let's hop back to the code and see how it works. You'll notice when we create the young people structure here, we aren't using any lifetime annotations. All the lifetime annotations will always be on the structure or function itself, as we can see it right here and right here. When we call the iter function on our IDs, iter automatically borrows all the items. So when we collect it, we're collecting directly into a vector of borrowed ID cards. On our young people structure, when we borrow the IDs by collecting all of our IDs into a vector, the IDs already exist prior to the structure being created. And since we have the type annotations here, Rust knows to check to see if there is indeed data that exists. it finds that there is IDs that exist, so it allows this borrow to occur. The next thing I'm going to do is implement some functionality on this structure. So I'll use the IMPL keyword, followed by the tick A for the lifetime, and we'll implement young people. When we do implementations that have lifetimes, we have to have the lifetime here after the IMPL keyword and after the name of the structure. Within the structure, I'm going to create a function that filters based on where the person lives. I'll name this function living in Fouville, so we'll see who's living in Fouville. We'll return a new young people structure when we run this. So what we'll have is we'll have our inner value. We'll borrow the current inner value, and we'll iterate over it. And then we'll filter by the ID. So when we call filter, we're filtering over this inner value here. So we're filtering over ID cards. So we'll check to see the city, and we'll see if it's equal to the Fouville city. We'll then map the results, and we'll just take out the ID, and then we'll collect it into a new vector. What's happening here with this map, when we call iter over it, we're going to have two borrows. So this initial vector is borrowed, iterating borrows again, and mapping with the asterisk will cause the borrow to disappear. And so we only have a single borrow, and that's how we can collect it back into a new vector of borrowed ID cards. Now we'll go utilize this function in main. So we'll filter our young people, and we'll change this to living in Fouville. And then we'll do young.living in Fouville. And hopefully we get all the young people who are living in Fouville. Let's hop back to the terminal and confirm. We'll need to call .inner.iter on this one. So now we have our originals up here, our young people here, and then here's our young people that are also living in Fouville. We'll hop back to the code just to recap real quick. We're creating a list of IDs here, and these IDs are owned data. So IDs owns the data. The young people structure is borrowing from those IDs, and that borrow occurs when we iterate over each one, since by default, iterate returns borrowed information. We collect all those borrowed pieces of information, place them into this young people structure here. So they're placed in this young people structure within this vector. We're allowed to borrow because we supplied a type annotation. And the type annotation just tells Rust that the ID cards that we're borrowing exist somewhere else. And we know they exist somewhere else because we created them right here. With our implementation block, whenever you have lifetime annotations on a structure, as we do here, you'll also need to include them on your implementation blocks. And to include them on implementation blocks, they just have to exist directly after the IMPL keyword. This concludes the demo on lifetimes. I'll see you in the next presentation.